Hi, everyone. It's Nate. Thanks for coming early in the morning to the Cool Science Festival stream. I'm excited to be here, even though I'm not in Colorado Springs anymore. I'm down here in Houston, Texas, where the Johnson Space Center is. Was excited to be invited by Mark and some of the other members of Cool Science Festival to talk about what I do here at NASA. And although I couldn't be on site to show you some of this cool stuff we have there this year, I assembled a video with some imagery, some videos that will hopefully show you a little bit about the spacecraft that we fly our NASA astronauts on. So without further ado, I'll get that playing. My name is Nate, and I'm training to be a flight controller here at the NASA Johnson Space Center. That means I'll be one of the people on the ground supporting astronauts as they work in space. After growing up in Colorado and participating in the Cool Science Festival the past few years, I'm excited to be back, even if that means virtually. My focus as a flight controller is in visiting vehicle operations, which means I care about how astronauts get to and come back from space, in what we call spacecraft or space vehicles. I put together a video to show you how our astronauts get to work, what's called the International Space Station. Humanity has always been explorers. We've explored the ocean by ship, explored the skies by plane. And almost 60 years ago, we started exploring space, where we explored other worlds like the moon. Nowadays, and for the past 20 years, we're using the space close to Earth, what we call low Earth orbit, with the International Space Station, where astronauts from all over the world visit to do things like perform spacewalks, conduct science, have pizza parties, exercise, play music, have their hair cut, and take photos of the Earth below. But how do astronauts get to the space station? Well, just like most of us might get into a car to travel to work, astronauts use spaceships, or what we call spacecraft. These spacecraft are placed on top of a big rocket, which is then lit up almost like a controlled firework, and after a few minutes goes so far up into the sky that they're in space. With enough speed and height, they don't fall back to Earth, but begin to orbit around it. Here's how the famous scientist Sir Isaac Newton thought of it. If you put a cannon at the top of a very high mountain and fired, the cannonball would eventually come back down to the Earth's surface. But if you cranked up the power on the cannon and put it on top of a mountain all the way up in space, then the cannonball would never fall back down. A rocket acts both as the mountain and as the cannon. It gets a spacecraft all the way into space. Then it acts like a cannon, making it go so fast that it can't fall back down. For the past 9 years, the only way NASA astronauts could get to the space station was by teaming up with Russian astronauts, called Cosmonauts. We would partner with them and squeeze into their spacecraft, called the Soyuz, which, as you can see, is a tight fit. Only 3 people can fit inside it. The Soyuz first carried humans to space over 50 years ago, in 1967, and the design hasn't changed much since. Weighing over 15,000 pounds and 24 and a half feet long, Soyuz is one of the lighter human-rated spacecraft. The Soyuz has 3 different sections in it. First, the orbital module. This is where things like the toilet are placed. Next, we have the descent module. This is where the crew sits on the way up and on the way down. And lastly, we have the instrumentation and propulsion module. This is where all the computers and fuel are. To get to space by Soyuz, astronauts and cosmonauts have to travel all the way to Kazakhstan, where the Baikonur Cosmodrome is. Here, on launch day, astronauts and cosmonauts climb up a tower into the Soyuz, which sits on top of the big Soyuz rocket. When it's time, the Soyuz engines will light up to full speed. The launch arms that hold the rocket up will move out of the way, and the spacecraft and rocket will start climbing into the sky. For about 2 minutes, the 4 booster parts of the rocket will burn up all of its fuel and then be ejected off the rocket. Then, about a minute later, the shell around the Soyuz spacecraft will be ejected, letting the astronauts see outside the window. Then, the second stages and third stages of the rocket will burn all their fuel and eventually detach, leaving just the Soyuz spacecraft with the astronauts inside. After that, the Soyuz's solar rays will deploy out and start using the sun's power to help it travel to the International Space Station. After a couple hours of chasing the ISS, the Soyuz eventually creeps up to one of the docking ports and makes contact. Once everything is sealed up, the astronauts on the space station can welcome their friends in and celebrate the journey they took. When their mission's over, usually about 6 months long, astronauts come back in the same ride they came up with, plunging back through the atmosphere and parachuting down to the ground in Kazakhstan. The next Soyuz launches on this upcoming Wednesday, October 14th, where NASA astronaut Kate Rubins will join Russian cosmonauts Sergei Ryzhikov and Sergei Kudzvertskov for a 6-month expedition aboard the station. Although we enjoy working with our Russian teammates, it costs a lot of money to send our astronauts on Soyuz. So NASA started something called the Commercial Crew Program, where we partner with American companies to develop new spacecraft for astronauts to launch on. One of these spacecraft is called Dragon. It's developed by a company called SpaceX. And just earlier this year, it launched for the first time with crew aboard. After about 10 years of development, SpaceX made a spacecraft that can hold up to 7 astronauts, which launches them from Florida on top of the Falcon 9 rocket. NASA's planning to only send up to 4 astronauts at a time, though, to give them some room for experiments. And their toy dinosaurs, or what we call zero-G indicators. The SpaceX Dragon is a little bigger than Soyuz, weighing over 20,000 pounds and standing almost 27 feet tall. It has 2 main sections, the crew module, which is where the crew sits, and the trunk, which is just like a trunk on a car. It's where you store stuff that you might need later. Like I said before, Dragon is bigger and therefore a bit roomier than Soyuz. You can see a couple astronauts that flew earlier this year, Bob and Doug, floating around. And here they are using the 3 big touchscreens they have. When it's time to launch, astronauts travel to the Kennedy Space Center in Florida and enter the Dragon at the top of the Falcon 9 rocket. When it's time to go, the countdown starts. 3, 2, 1. And the Falcon 9 rocket lights up. After a few minutes, the booster stage uses up most of its fuel, then comes back down to Earth and lands. With the help of the second stage, more fuel burns, getting Dragon high enough and fast enough to eventually reach the space station. The second stage then separates and leaves Dragon on its own to catch up. After a few more hours, the Dragon begins slowly and safely approaching the station, just like Soyuz. The top of the Dragon, called the nose cone, opens up, revealing the structure which attaches to the docking port. After safely connecting, the door opens and astronauts can float in and start getting to work. Once the mission's over, astronauts pack up their belongings and suit up for the journey home. First, the Dragon slowly departs the station. Then, before performing what's called the deorbit burn, the trunk is released, so Dragon can orient its heat shield towards the Earth before plunging through the atmosphere, slowing down, just so it can deploy its parachutes and gently touch down in the ocean. A ship then picks up Dragon and lets the astronauts out, letting them get their first breath of fresh air in months. The next Dragon is currently scheduled to launch super early on Halloween Day. Be sure to mark it on your calendar. This time 4 astronauts will be strapping in, so it might be a little more snug. To hype you up a little more, here's a promotional video NASA released just a few days ago.
3, 2, 1, 0. Ignition.
America has launched. So rises a new era of American spaceflight, and with it the ambitions of a new generation continuing the dream.
We're already counting down the days until Crew 1. That'll be the first operational flight in a Crew Dragon spacecraft. Mike Hopkins, Victor Glover, Shannon Walker, and JAXA astronaut Soichi Noguchi are to be the first multinational crew to fly in this new capable vehicle. This mission marks the return of a full crew complement to the International Space Station, and together they will celebrate the 20th anniversary of continuous human efforts on board the station.
We still have one more spacecraft to talk about, which will also be bringing NASA astronauts to the International Space Station. This one is developed by Boeing, and its name is the Starliner. It has been in development alongside Dragon, also as part of the Commercial Crew program. Although no astronauts have flown in it yet, there's some similarity to the other 2 spacecraft I talked about. The Starliner is the shortest one of them all, at 16 feet tall. However, it's the heaviest one, weighing over 28,000 pounds. That's a little more than a school bus. Like the Dragon, Starliner is designed to fit up to 7 astronauts, but NASA will only allow 4 on board. It also has 2 main sections, a crew module and a service module. The Starliner will launch from an Atlas V rocket, which is currently the most reliable rocket yet. Just like Dragon, astronauts will travel to the Kennedy Space Center, Florida, climb up the tower and into their spacecraft before being propelled into space. Once in space, the path is similar to its counterparts, but one unique aspect of the Starliner is how it returns to the surface. As unlike Dragon, it lands on land, making it the first American-made capsule to touch down on rigid ground. That was a glimpse into the 3 spacecraft NASA astronauts used to get to the International Space Station. First, we have the Russian Soyuz. Second, we talked about the SpaceX Dragon. We ended up with a Boeing Starliner. Don't forget, we have 2 launches coming up, one on the 14th and the second on Halloween Day. Thanks for watching. My mic was muted, of course. That was my video just showing the 3 spacecraft NASA astronauts will be taking to the International Space Station in our current age. I left out some in the future. We'll be using other spacecraft. For example, Orion is a big one that we're going to take to go to places like the moon in the future. But those are the 3 for low Earth orbit. And so that's where the space station is. Just when you look up in the sky, you can actually see it sometimes. I'll answer some questions in the chat. If anybody else has more questions about anything that I could potentially answer, feel free to comment them. So I see Autumn Mort reads, so cool. What's the biggest difference between life in space and life on Earth? What ways are they similar? So I was thinking the biggest difference that a lot of astronauts say is just how confined you are, because the space station is, although overall it's about the size of a football field, a lot of that is solar arrays and stuff you can't actually get into. So it's really just like a couple long hallways that they live in. And so
it's actually kind of similar to how we've been living this year quite a bit, with how things have been closed down and we've been recommended to stay in our own homes and all that. So we've had a taste of what it's like to be an astronaut, with planning, say, groceries every 2 weeks and getting stuff delivered to us rather than us going out to get them. Similarities, I think the big one is they still get to have fun. So as you saw, they were playing with the dinosaur, recording fun videos. They take photography out the window in their spare time. They get to watch movies. They have a lot available to them when they're not working. And so the program does a good job of trying to make sure they have a normal work day just like us on Earth, and still get the time to do what they can while there. They also get to do the same stuff we do around the house. So they have to vacuum up every weekend. They have to prepare for work the upcoming week. So not completely different than what we're used to down here. I see another question. Amber asks, Eddie wants to know how fast the space station is going. Hi, Eddie. Thanks for watching. The space station is going over 17,000 miles per hour. So that's really, really fast. And that's why we need rockets to get up there. We can't just say slingshot ourselves up or reach up and grab it. So you have to go really, really fast and really high up, of course. And that when you're that high up and orbiting, that means you go around the Earth, which is really, really big, every 90 minutes or hour and a half. Let's see. I think that's about all the questions I see at the moment. To fill up a little more time, I was going to show a couple more spacecraft that we have. So if I can find the picture. Well, I can't find it at the moment, but I'll talk about a couple spacecraft coming up. So one is a spacecraft that's going to be delivering cargo, and this is actually be built from a company in Colorado called Sierra Nevada Corporation. And so they have something, I have a plushy version of it. It's the Dream Chaser. And so it looks kind of like a spacecraft that we used to use to take astronauts to the space station, but was retired in 2011, called the Space Shuttle. But this is a cargo craft, so it's only going to carry supplies to the station. So things like groceries and science experiments and all sorts of new tools. And so this is in development right now, and we're hoping to see it flying in a couple years. This is going to be a spacecraft that myself and my colleagues are going to work with members of their team to make sure it flies safely to the space station and brings up their supplies. Another cargo spacecraft, so the ones I showed in the video were crewed spacecraft, meaning astronauts are on it. Cargo spacecraft are ones that, like I said, bring up cargo supplies, groceries. So Dream Chaser is one that's upcoming. For the past 10 years, we've worked with Japan's space agency called JAXA to bring up supplies as well. And they've done that on the HTV cargo craft. And so they recently flew their last mission, HTV-9, and they're making a new advanced version with HTV-X. And so HTV-X is an advanced kind of version of it. And you can see here's a paper model that I put together. They have on their website. If you search on, I believe, jaxa.jp, it's all in Japanese. So you'll have to do a little bit of translation, but they have paper models you can print out and stuff of their spacecraft. So this is HTV-X. So it's very similar. It has different portions. But one thing you see in a lot of spacecraft are these things called solar arrays. And so you might see these on top of people's roofs in your neighborhood, for example. And what these do is take the sun's energy. The sun emits these invisible things to our eyes called photons. And these panels absorb them and convert that into energy. So that's how this can recharge its batteries on the way up. And so you can see here on the front, there's a little port. And so just like, say, Dragon goes up to a port and docks, so will HTVX. It'll go up and dock, and then they can seal the latches because you don't want any of the air in the space station to escape. And you can dive in and start pulling your groceries out. And then when these cargo craft are done with their mission, you fill it up with trash, any sort of waste you have, and some of them come back down to Earth and slam into the atmosphere on purpose to burn up in the atmosphere, to get rid of whatever's on board, because we don't need them anymore. And it's expensive to bring stuff down and use parachutes. So sometimes that's an answer. Sometimes we want to bring them back. And so that's where things like the Dragon will come in and land back down, and we can get those experiments and look at how they behaved back on Earth. I see Natalie Cordova saying, so big Earth rocket, right? So yeah, because our Earth is so big, you need a rocket to get to escape the atmosphere and go into orbit. Because if you if you don't go up high enough, you're just going to fall back down. Now, if you're on, say, other planetary bodies, so like the moon, for example, you don't need necessarily as big of a rocket. And that's because it's a smaller planet, or it's really a moon. And so the gravity that pulls you down, the thing that's making me sit in this chair and not float around, the gravity is less there. And so you don't need as much fuel. And so that's one thing that we're hoping to take advantage of in the future when we set up bases on the moon. Let's see. I don't see any more questions in here. But I will leave it at that. Thanks for watching. Like I said, we have a couple spacecraft launching this month. So we have the Soyuz, which is launching on October 14th. You can go on NASA's website and they'll have more of the details there. They stream that live, so it's really fun to watch. It's not always at a good time schedule, so sometimes you'll have to stay up late or wake up early, and that's something I have to do as part of my job too. So you can get a taste of that. And then we have the big Crew Dragon launch, which is the first operational mission, as you saw, scheduled for the 31st, although due to weather and so many other things involved, it could be pushed. So anyway, thanks for attending, and be sure to watch some of the other shows that are going on. There's a lot of cool stuff with the Cool Science Festival. Thank you.